Hi everyone, welcome to my channel Love for Structures. I am Professor Shourav Kaur and I will be discussing on a very critical point or critical section in a problem regarding cantilever method of analysis frames. In the cantilever method of analysis for frames, let the frame be a multi-studied frame. In those cases, what is the main thing we have to do some consideration that I will discuss today. Many of my engineering students, they face this problem regarding this cantilever method problem because this problem is a very bit critical compared to portal method. We all know in order to analyze any indeterminate structures, we usually go for slope deflection method and moment distribution method for beams, for continuous beams. We can use Canny's method to solve the indeterminate beams as well as frames, and to understand or to analyze any structure, any frame which is subjected to only lateral loading or horizontal loading which comes on the structure due to wind loads or seismic loads, that can be dealt with the portal method and cantilever method. I hope you have gone through all my previous video lectures where I have elaborately discussed the basic concepts of portal method and also have discussed a big problem on portal method. Even I have also discussed fundamental principles of cantilever method, as well as I have discussed the problem on cantilever method. This video is specially made for particularly the critical portion on a problem of cantilever method where the lateral forces are resisted by the individual columns at each and every floor level for a multi-story building. So let's start with my presentation. Let me start the presentation. By and by, you will able to observe what I will be discussing in this method. So in the subject of analysis of structures 2, or in some engineering colleges all over India, this course is being taught in the third year or second year of the civil engineering course, the undergraduate course, taught in all engineering colleges, even IITs and NITs. Is one of the very pivotal subject for a civil engineer to learn. In this analysis of structures 2, we mainly deal with the indeterminate structures and indeterminate frames. Today, as I told you, I will be mainly focusing on the cantilever method of frame analysis. I am Professor Shourav Kaur. I have been attached with Heritage Institute of Technology, Kolkata, for the last 4.5 years. The code of the subject is CIVL 3101, the subject of this code, as in our institution. Mainly, I have been attached with this institute for the last 4.5 years. My research interests are concrete and cement and concrete composites. I have earthquake engineering as my research interest also, seismic analysis on tall structures. I have interest in geopolymer concrete, self-compacting concrete, ultra-high strength concrete, even on an emerging topic, which is repair and rehabilitation of concrete structures and RCC design. Till 2020, I have my 4 conference papers fully published and 4 journal papers published in peer-reviewed journals. So this is the course importance, which is usually observed in many of the institutes, that primarily it has got a credit of points of 4. Merely this is the overall scheme of all the engineering institutes, not only in our institute, but all of the engineering institute all over India. It's a very important subject and gets the highest, or it possesses the highest credit points of 4. So today, which I was discussing, that in the module 4, we have 4 modules. Under module 4, we have this approximate method of analysis of frames subject to lateral or horizontal loading. We have the portal method and cantilever method for multi-story frame. Usually we have learned slope deflection and moment distribution for a normal portal frame we have usually undergone. But in this particular module, in this topic, we will be basically deal with what is the effect of the lateral forces acting on a multi-storied frame, which may start from 2-story to minimum any number of stories. So more the number of stories, more is the complexity of the frame. So in my problem, so I already have discussed the basic concepts on the cantilever method. If you visit my earlier videos from the love for structures, you can get all the video lectures. So I would request you to like and subscribe my videos and share it to more and more students, not only on this topic, but also I have video lectures on pre-stressed concrete design. I have video lectures on the design of curved beams. Also have video lectures on all these matrix method, particularly stiffness method and flexibility method, how to solve the structures. Coming to this problem, we have analyzed the frame shown in the figure below by cantilever method. So basically, we will be solving the question using cantilever method, which is a bit critical, more complicated and time consuming method compared to portal method. But very interesting is that it is basically more accurate compared to portal method. So basically, we will get a multi-story frame, and here in this problem, it is given that the area of each extruded columns, the area of each individual columns is half of the area of the interior columns. Okay, so this is a special criteria which is given in this problem, but not always. Do not think that always this criteria or such criteria or exclusive point will be given. If nothing discussed or nothing such criteria is given based on the area of columns, we will assume all the area of the columns be same. So now coming to a frame, we have here, if you see, we have 3 bays, first, second and third. We have 3 bays, which is center to center distance between columns. And also we have 3 stories, that is 3 by 3 frame. Okay. So we have the base of 8 meter, 6 meter and 4 meter respectively. And the floor heights are all same, 4 meter each. 4 meter each. And the loads are lateral loads which are subjected. The frame is 40 kilonewton at the topmost. Then we have the 80 kilonewton at the second level. And again we have the 80 kilonewton lateral force coming on the first level. That is, here this is floor level 1, this is floor level 2, and this is floor level 3. Whenever we get such multi-story frames, our first task is to find out the degree of static indeterminacy, that is DS. Obviously, it is quite important that DS, we have to learn, or we have to know how to find out the degree of indeterminacy on a structure, which I hope all of you know. And if you need any such videos on how to learn the degree of indeterminacy, you can post in the comment box. Like, I will surely make a video on that topic. How to find out the degree of indeterminacy, static indeterminacy? It is completely nothing but the number of bays multiplied the number of stories. It will be nothing but just the number of bays multiplied with number of stories. So that is the total degree of static indeterminacy. Okay. So this is the main concept. So this is the frame. So this is the, what should I say? This is the portal frame where we have to analyze what remains in the analysis part. Analysis remains basically finding out the shear force and bending moment acting at all the columns as well as all the beams. All the columns and all the beams, the shear force and bending moment is very important. So coming to this solution first. So basically, if you check this, if you find out this, so that means as per the criteria, if the area of the interior columns each are A, then for the exterior column it will be twice A. Okay, sorry, just pardon, just the reverse, just the reverse one. That means if we have the interior columns as twice A, then the exterior columns will be A. Okay, simply the exterior columns is half of the interior columns. Simple. Okay. Now, so first, what is the task? We have to obviously find out the degree of static indeterminacy. Also, we have to find out the CG distance. If you see this line, this is basically a line drawn drawn by a pencil, which we don't know the distance. The CG of all the area of the columns, mind it, this is the line of CG of all the columns, which is acting at some distance, more or less at the midsection of the whole total frame. Okay. So the first thing is that we have to find out the distance of CG of all the area of the columns. Okay. So the first thing is that we have to find out the total area. So area of the n columns is taken A. So area of the intermediate columns will be 2A, as I told you, as per the criteria given in the question. So the total sum of the area will be 6A, A plus 4A, 6A. Now, we have found out, if we do some calculations, taking the moments of the area of the columns, taking the moments of the area of the columns. Mind it, I'm again telling that we will take the taking the moments about the axis of columns A, B, C, D. So taking the columns, we are getting a distance of 10.33 meter. The 10.33 meter has been calculated from this distance. If you check, if you just very accurately, if you just check my PDF, so this distance, this which I'm marking, this distance is 10.33. Okay, that is the distance of the CG from the extreme-most left column, which we have taken as a reference column. That distance is coming 10.33, which we represent it by x bar. Okay, we represent it by x bar. Okay, so the x bar is nothing but the distance of CG, 10.33 meter from the reference column, which is the extreme most left column of the frame. You can take any frame, you can take any column of the frame as a reference, and you can find out the distance of CG. Okay. Now coming back to this, so we have got the distance of CG from the extreme leftmost column. Also similarly, by and by, we will calculate this distance, the distance of CG from the second column. Similarly, this is the distance drawn from the third column to the CG. And the last is, this is the distance of the fourth column from the CG. The last distance, this is the distance of the CG distance from the fourth column. So basically we will find out this value. So we will getting 4 different values. That is the main important thing. Why we are finding out this? Because if you have gone to my lecture classes previously, one of the assumptions in a cantilever method is that the stress acting at each and every columns, if you check, the stress acting at each and every individual columns is directly proportional to their CG distance of those columns with respect to the CG. That is why since I am requiring the distance of all the individual columns with respect to the CG distance or the CG line of CG, we have to find out the distances. And also the CG distance, CG line particularly, we have to draw using some pencil beforehand, because we might do some mistakes while drawing this line with a pen. The better you use this pencil, because we don't know the distance of this CG before calculation. So similarly, I just told about that we will represent all the CG distances. We have here, I have represented the X bar as X1, second from column 2 is X2, third is X3, and fourth is X4. Okay. And also there is another important concept, that this dotted line is the CG. And from the second assumption, just I told you regarding the concept of proportionality, that is the stresses acting at each and every column will be proportional to their distances of that respective or specific column with respect to the CG. That means if I take the stress at column 2, then this stress at column 2 will be proportional to the distance from the CG. Okay, correct. So using that proportionality concept, we have drawn similarity triangles. If you check, we can simply, using that assumption, we can draw the similarity triangles. Okay, so the C distance from first column is 10.33, second column is 2.33. This is how we are getting this. We are getting by that 8 meter, the bay length 8 meter plus 6 meter. This is 8 meter plus 6 meter minus 10.33. Again, if you take the 3.67, the third column, that is nothing but the 8 plus 6 meter minus 10.33. And for the second column, I did a bit mistake. For second column, it will be 10.33 minus 8 meter. That is coming 2.33. And finally, the last one, which is coming 7.67 meter, is nothing but 8 plus 6 meter plus 4 meter. Just correspondingly, progressively add the bay lengths 8 plus 6 plus 4 minus 10.33. This is how we will get all the distances. Now, next thing is that if you see, you go just coming back to this picture, we will demarcate, or we will represent all the axial forces on the left side of the CG as downward, which is tensile. So as the frame to be in equilibrium, we will demarcate, or we will represent all the axial forces. Why we are taking the axial forces? Because axial stress is nothing but axial force divided by area. So axial forces acting on all the columns which are present to the left of CG line, this dotted line is tensile, and the axial forces acting on the columns which are present to the right side of the CG will be compressive, that is upwards. So tensile will be downwards, left of CG, and compressive will be upwards to the right of CG. See, similarly, so to represent all the axial forces, I have taken the axial force in column AB, which is the leftmost column, as V1. So using the similarity triangles, for different columns, EF, IJ, that is the second column, third column, we will represent all the axial forces with respect to V1. That is, the axial force is column, if it is V1, then the axial force in column 2, that is second column EF, is 0.45. If you check the frame, this is AB, this is EF, all these things. So even for IJ, the third column, it is coming 0.71 V1. And lastly, for the fourth column, if you check the fourth column, that is for fourth column, I am getting the proportionality of 0.74 V1. That means all the axial forces in all the columns, they are represented as a proportion of V1. Why I'm representing this V1? Just so that V1 will be the one unknown item. Okay. Now the second stage is just to calculate the moments with respect to this point. This point is nothing but the point of contraflexure of the first column, or the point of contraflexure of the column of the first floor. So taking all the moments, the clockwise moment and anti-clockwise moment, the actual force is coming 52.90 kilonewton. Okay. So if you check, if you don't understand, basically this is nothing but we are taking, see, we are taking the moments about the point of contraflexure of the beam AB. So taking the point of contraflexure as the reference point, so we are having the lateral force 40 kilonewton, 40 into 10, 80 into 6, and 80 into 2. These are all clockwise moments from left to right. And also we have 0.45 V1 into 8. That is the actual forces which is coming on the column 2. That is also clockwise moment. And anti-clockwise moments are 0.71 V1 into 14. 14 is basically the bay length, 8 plus 6 meter. And 0.74 V1, that is the actual force in the fourth column, 0.74 V1 into 18, 8 plus 6 plus 4. So doing all these things, we are getting only one unknown is there, that is V1. And V1 we are getting 52.9. Similarly for story 2, this one for story 1 actually. Okay. The first thing what we do is that we calculate the actual forces story wise from bottom to top, not top to bottom. We do from bottom to top. Okay. If we consider story 2, similarly if we consider story 2, then we will cut the one column of story, we will cut the column on story 2 at the point of contraflexure, which is basically acting as the midpoint of beam and column also. Always remember when we are analyzing portal method and cantilever method, we know that the point of contraflexure always acts at the midpoint of the columns and beams. So for story 2, similarly we have got the actual force, the proportion of actual force will remain same. Just like we have taken for V1, similarly for story 2, we have taken V2. And taking the moment about the point of contraflexure of the column of story 2, we have got V2 as 20.35 kilonewton. Similarly for story 3, the proportional actual forces remain same. And here just we are representing for story 3, we are representing V3, and V3 is coming 4.06 kilonewton. Okay. So by and by, whenever we are finding out this V1, V2 and V3, we are going on continuously cut the columns at the midpoint. Okay. We for first to calculate this V1, we are cutting the first column like this, like if you go back to the original diagram, that means to calculate this V1, we are cutting this first column. For V2, we are cutting this second column. And for V3, we are cutting this third column in respective stories. So we have got V1, V2, V3. So this is how we represent the proportional forces which coming in all the floors. For floor 1, we have taken V1 as the standard reference axial force. For story 2, we have taken V2, and for story 3, it's V3. So based on the proportional, so for column 1, it will be V1. For column 2, it will be 0.45 V1. For column 3, it will be 0.71 V1. And for column 4, it will be 0.74 V1. Similarly, if you come to the second story, V2, 0.45 V2 like this. And similarly for third story, it will be V3, 0.45 V3 like this. Okay. So this is how progressively we will first, using the concept of second assumption, we have found out the axial forces, even also axial stresses acting at each and every column. Now coming to the main concept, that is second part, that is calculation of shear force in beams, in columns. So these are nothing, V1, V2, V3 are the axial forces, not the shear force. And the second point is calculation of shear in columns. Okay. Now to calculate the shear force acting in the columns, in Portal method it is quite easy. In Portal method of frame analysis, we know that the shear force taken by each exterior column, or the shear force taken by each interior columns, will be double that of the shear force acting at each exterior column. That means if the exterior columns, the outside left and right, the extreme most outermost columns, if their shear force is V, then the inside, all the inside interior columns will be twice V. Simple. But here the concept is completely different. It is not so easy. This is a very tricky part and the lengthy portion. Okay. So now to calculate the shear force acting in the columns, we will go from top to bottom. Okay. Always remember, we will, to calculate the shear force, we will go from top to bottom. So considering story 3, see in the story 3, which portion I have taken cut? I have cut the portion of the point of contact flexure of the topmost column. That is, if we taking about story 3, that is the third level, the floor level 3, then we are cutting which portion we are taking? We are taking the portion of, if you just show this part, okay. If I show this part, let me erase all the previous markings. Now for first portion, I will cut this portion, that is the point of contact flexure of the column CD and the point of contact flexure of column DH. Okay. So taking this part, see, I have represented the downward force V3. Downward force means the tensile force because it is left to the CG. H3 dash, that is the shear force of the first column in the third story, that is H3 dash. I have represented, which is unknown. Now I have 40 kilonewton load acting here at this point, 40 kilonewton, and also I've shown the distances. So I will take the moments about the point of contact flexure of this point, D dash. So I will basically, to find out the shear force, we will take the moments about this point of contact flexure of beams. So taking the moment at this point, if we check, that is H3 dash into 2, H3 dash into 2, that is, this is the horizontal one. So if I represent, so also here we will consider all the clockwise moments and anti-clockwise moments. So if you check this H3 dash, the horizontal force multiplied with the perpendicular length 2 meter, that is equals to, so this is basically the clockwise moment, this one acting on the left side of the D dash. Consider D dash is the standing point. This is the reference point, this is the standing point. With respect to this reference point, H3 dash into 2 is the clockwise moment, and V3 into 4 meter. If you check V3 into 4 meters, that is nothing but the force into the perpendicular lever arm. Perpendicular lever arm, that is, the lever arm can be horizontal, can be vertical. For this horizontal shear force H3 dash, the lever arm is 2 meter, which is vertical, and for V3, which is the vertical force, the horizontal length is 4 meter, which is lever arm. So taking all these things, we have got the shear force H3 dash as 8.12 kilonewton. Okay, which is nothing but the shear force in this column. Basically, the H3 dash is nothing but a shear force. I told you, the shear force in the beam DC or column DC. Again, now we will what in the second part. So H3 dash is now known, no problem. Now coming to the third part, that is the second part, that is H3 double dash. which is unknown. So I have taken what I have taken. Now coming back to this diagram, now I'm extending this portion. I'm cutting this column HG and I'm cutting this beam HL. So my main aim of the area of concern will be this one. Okay. So I have cut this portion HG, the point of contact texture of HG, and I've cut the portion point of contact texture which is midpoint at HL. So come back to this calculation. Obviously, I will be representing all the vertical forces. Obviously, for the exterior column, we have got V3. Now, for the second column, it will be 0.45 V3. That is the proportional factor. And H3 double dash is unknown. H3 double dash is unknown. We have to find out. Now, to find out is H3 double dash, we will find out the moments about this point. That means we will find out the moments about the point of contact flexure of the beam HL. Okay, so taking all these point of clockwise moment and anti-clockwise moments, we are finding out we have got H3 double dash is 16.95 kilonewton, which is the shear force of this beam HG. Okay. Okay. Now coming to third one, that is H3 triple dash. To calculate the third shear force, again we will just extending this portion. We are cutting this part and this part. Okay. So if you come to this picture, now we are cutting the point of contact flexure, the midpoint of LK and midpoint of LP. Okay. Now taking all these consideration, we will consider H3 dashed, which is known, H3 double dashed, which is just we have calculated, and H3 triple dash, which is a big question mark, which we will find out. So to find out this H3 triple dash, we will find out the point of contact friction, or we will calculate all the moments about this point of contact friction which I am marking. So we will take all the clockwise moments and all the anti-clockwise moments. If you check whatever the clockwise moments are coming, if you check H3 dash, H2 triple double dash, and H3 triple dash, they are all clockwise moments. And the anti-clockwise moments are V3, then 0.45 V3, this one, V3, 0.45 V3, and 0.71 V3, which is also clockwise, so minus. We could have done that this portion we have transferred to here. This we could have been done. Okay, no problem. So just making this point as reference, we have to first identify which are the clockwise forces and anti-clockwise forces. Then only we will put errorlessly in the moment equation, where we are equating the clockwise moments and anti-clockwise moments. Okay. So we have got H2 triple dash, the shear force of LK. And finally, the H3 4 dash, that is, we will get 3.09. That is nothing but the last one, the last shear force in the last column. We will just subtract 40 minus 8.12 plus 16.95 plus 11.84. Okay. For the last, to calculate the shear force in the last column, we will just subtract from 40, because 40 is the only existing lateral force. Now coming to this portion, if you check this diagram, now our main task is, so this is H3 dashed, second is H3 double dashed. You can demarcate in any symbols, no problem. Okay. For third column, it will be H3 triple dashed, and then for fourth column, it will be H3 dashed 4. Now coming to the second portion, or the second floor level, we will take this portion. We will take this portion. Okay. So just come to this problem. So here, if you check in this portion, so what are the here the from the for the first floor level, sorry, for the third floor level, the topmost floor level, the critical concept is less. The hardness or the tough is it is less tough. But when you go for the third and first floor, more number of forces will be coming to play. Which are the forces? Now, if I take now just imagine if I take this portion or if I erase this part, the shear forces which were acting from right to left, which were resisting the horizontal shear, when we will consider this portion, that means we will cut the portions of columns, the point of contact fixture of the column of the above floor, connecting floor, and also the column of the connecting floor, which is second. So whenever we are considering the forces, the horizontal shear of the top floor will be just the opposite. Obviously, in addition to the original lateral forces given in the question, that is 48 kilonewton and 80 and 80, just the shear force which you have got from right to left, they will be reversing their directions because equal and opposite shear is acting at this point. And these equal and opposite shear forces have to resist by this horizontal shear at second floor level. So that is why if you consider this part, so we will take the shear force H3 dashed from the left to right. Okay. So here the direction is just changing. Okay. So at this point, it is not just changing, it is basically from the concept. So here we have H3 dashed into 2, which is clockwise movement, plus V3 into 4, which is clockwise movement, plus H2 into 2, which is unknown, H2 dashed. So we are getting H2 dash equals 24.46. That means in this stage, how it is coming, please make sure, my dear students, H3 dash has changed its sign. That is in the previous stage, it was from right to left. Now it is from, if you check, it is from left to right. Also H3 double dash, it is from left to right. And also the axial forces, they have changed their directions because we are considering equal and opposite direction. So V3 is upwards, which was earlier downwards. 0.45 V3 is upward. Also V2 is downwards because it is still under consideration. Okay. So from here we will first calculate H2 dashed and similarly H2 double dashed. Okay. So the main concept is that here two important things: the shear force which I have got in the values, the shear force values will be same. Just the direction of the shear force of the columns which are from right to left. While considering the second floor, it will be from left to right. This one like this, they're from left to right. And also the vertical forces in the column, axial forces which were tensile, now they will become compressive. Not because they're compressive, because we know that if you check this diagram, just like this, see, equal and opposite axial forces, equal and opposite axial forces is coming. Okay. So that is why we are considering all these forces, where this sign, their symbols are changing. While you will obviously say that why are the symbols of V2 and 0.45 V2, they are still same? Because now we are considering the story 2. That is why their original directions will be same. Okay. Similarly, we can calculate H2 double dashed. That is the shear force in the second column. Now we have also, if you check, we have extended this diagram. H2 dashed we have gone, H2 double dashed we have found out. Now our thing is that H2 triple dashed is unknown. And similarly, if you check H3 dashed, H3 double dashed and H3 triple dashed have changed their symbols from left to right. And also V3, and also if you check the actual forces, V3, 0.45 V3 and 0.71 V3, they've changed their directions. Obviously, as I told you, we will take the moments, clockwise and anti-clockwise moments about this, that is the point of confliction of the beam, and we will consider all the clockwise moments and anti-clockwise moments. Okay. Now, if you check H3 dash, H3 double dash, and H2 triple dash, they are clockwise. Similarly, V3 into 16, this moment is clockwise. 0.45 V3 into 8, clockwise. 0.71 V2 into 2, this is clockwise. Also, these are clockwise. Also, H2 dash, H2 triple dash, H2 triple dash, all these are clockwise moments. While the anti-clockwise moments remains V2 into 16 plus 0.45 V2 into 8 and plus 0.71 V3 into 2. Okay, all these things. Okay. So similarly, we have got H2 triple dash, that is the shear force in third column, and successively we will calculate the shear force in the fourth column. Okay. Now, how to calculate? How we will find out the shear force in the fourth column? See, the lateral force which are there now, it's coming 40 plus 80. Why? This effect of 40 kilonewton, the lateral force which was at the topmost level. If you check the diagram, see, if you check this diagram, let me erase this part. If you check this part, that is for first story, it will be for third story at the topmost floor, it will be 40. But whenever we are coming to the second floor, we will take the combined effect of 40 plus 80. Similarly, when we will come for the third floor, we will take the combined effect of 40 plus 80 plus 80, all these three lateral forces. So successively, whenever we are going, we are approaching from top to bottom, the correspondingly the lateral forces which are given in the question, they will be added. Now coming to the first floor level, the bottommost floor level, if you come to that portion, the same concept, okay, the same concept, okay, the same concept. So H1 dash we have got here. Similarly, in this portion, when we are considering the story 1, so H2 dash which we have calculated previously, they will change the symbol. Also H1 double dash, if you check the symbols are the direction that have changed. Even the actual forces, their directions have changed. Okay. So H1 double dash, H1 triple dash, similarly, and finally H1 dash 4. So see 40 plus 80 plus 80. Okay. This is the some of the three lateral forces which we have considered when we have considering the floor level 1. And finally, doing that, we will calculate after calculating the shear force in columns, we will calculate the bending moment. That is nothing but the formula is shear force multiplied with the span length divided by 2. Why this is? Because we are considering the shear force acting at the point of contact flexion. At every columns, we imagine or we we idealize that the shear forces are acting at the midpoint, which is the point of contact flexion. Okay. So similarly, we are calculating all the bending moment of all the columns. Let us, we have taken for story 3 first. Let me take story 3 for DC, HG, LK, and PO. For all the 4 different columns, we have found out the bending moment. Similarly, bending moment of columns, CB for second story. For first story, we have calculated all the bending moments. That is, bending moment of a column will be shear force multiplied with the span length, that is the column height, divided by 2. And also finally, we will find out the bending moments of the beams and shear forces in the beams. The method of calculating bending moment in the beams is completely similar to Portal method. Okay, it is not at all different. It is completely same as Portal method. We will calculate first the bending moment For story 2, for example, for story 3, we are considering the bending moment of all the beams. Similarly, for story 2, we are calculating all the bending moment of the beams. And for story 1, we are calculating all the bending moments in story 1. After calculating the bending moments, we will calculate the shear forces. Okay. And obviously, if you calculate the shear force, if you calculate the bending moment here, we have calculated. So the shear force will be what? Bending moment into 2 divided by span length. Just you reverse the equation. To calculate, if you know the shear force, if for example, if you check this formula, here in this case, what was the thing? We know the shear force. So bending moment will be shear force into span length divided by 2. And if you don't know the shear force, we know the bending moment, then shear force will be bending moment multiplied with 2 divided by span length. Just cross multiply this equation. Okay. Shear force is bending moment into 2 multiplied with 2 divided by the span length. This is how we calculate the shear force in column. Okay. So basically, what is the final thing is that in cantilever method, what we do is that first we are calculating the shear forces in columns. Second is we are calculating the bending moment in columns. Third, we are calculating the bending moment of beams, and then using the bending moment in beams, we are calculating the columns. So in columns, in cantilever method, for columns, first bending moment, first the shear force, then using the shear force, we are calculating the bending moment, okay? And after that, calculating bending moment in columns. Now using this bending moment of the columns, we are calculating the bending moment in the beams, and then we are calculating the shear force in the beams using the bending moment of beams. Okay, so all their interlinked steps. Very, very nice, and it's a very, very critical and a very accurate method of frame analysis subject to lateral loading, and also it is much accurate. Thank you very much, my dear students. If you want more video lectures on structure analysis, you just comment, you just like, subscribe, and share to many, many civil engineers, budding civil engineers all over India. And for many detailed lecture videos on different subjects of structural engineering, you can comment me in the comment box. Thank you very much.